I am now going to start recording. So basically, thank you everybody. Basically, the lessons, what I like to do is record the lessons because sometimes students, they like to, they like to listen to the lesson again. So this lesson is being recorded, and I'm going to just point out some things here for the differential equations. So you had differential equations when you took calculus 2. And so this here, this is a standard kind of differential equation. dy dx equals 0.2 times x times y. What is a differential equation? What does it mean? Well, a differential equation, okay, differential equation is an equation that contains derivatives of one or more unknown functions with respect to one or more independent variables. That's a differential equation. So you don't need to take formal notes on this. It's being recorded. I think it is good to take notes on some of the things when I start doing my own examples. But for now, you can just kind of listen. And if you have questions, feel free to ask. So these are some examples of differential equations. And let's see here, one moment. One moment, class. Okay, hold on. I knew this would, one moment. Okay, good. I'm in the Mind Tap. I'm in the thing here. So, okay, so just give me one moment. One moment. Okay, good. So you have what are called ordinary differential equations, and you have below there partial differential equations. So if you've taken multivariable calculus, you learned, that's Math 280, you learned about partial derivatives. Well, differential equations, there are differential equations that can relate partial derivatives or second partial derivatives to each other. And there's a class actually called partial differential equations. And that is usually taken in like a 4-year institution, like maybe your 4th year of college, or even graduate school. We are focused here on ordinary differential equations, like you see there on part A. Okay, these are ordinary differential equations. So let me just keep going down here. I really want to get to some examples. Okay, I really want to get to some examples. But one thing that's important is the order of a differential equation. So if you have a differential equation like you see in front of you, d squared y dx squared plus 5 times, in parentheses, dy dx quantity cubed minus 4y equals e to the x, that's a second order differential equation because the highest order of the derivative is a second order derivative. So differential equations, we can classify them in terms of the order of the differential equation, and it's the highest derivative in the equation. Okay, so sometimes too, differential equations have can be written in what's called differential form. Okay, and that's not a form that you've seen of a differential equation, but a differential equation can be written in what's called differential form. And in your homework, you will see differential equations sometimes written in differential form. Okay, so like for example here, in this first example, they give a differential equation that you see here. Here's the differential equation. Now let me ask, what's the order? What's the order of that differential equation? That's right, Sherman. It's a first order differential equation. That's right, Joel, because there's a first derivative there. Okay. Now, what if we want to put this in the form that was mentioned above, in differential form, we can, well, we can manipulate it. So what they're saying is, you see, unfortunately, I can't highlight two things at once. At least I don't think I can. Let me see. Can I? No. So this is the differential form of the differential equation. And if you were to divide the entire differential form of the differential equation, if you were to divide it by dx and rearrange the terms a little bit, you would get, well, actually, if you just divide that by dx, you would get this form of the differential equation. And sometimes one form is more convenient to use than another form. Okay, are there any questions on that? Are we okay with that? Okay, all right. Well, let's keep rolling here. Okay, now here's an example where they take a regular differential equation and they write it in differential form. Okay, and basically, if you multiply through by dx, you can see that that'll happen. So it's not a big deal, but I just wanted to make you aware of it. You're going to be seeing a lot of new things naturally in this course, even though you've seen there's some differential equations in calculus too. Okay, so let me just keep going on down a little bit. So a differential equation, sort of the normal form of a differential equation, is dy dx equals a function of x and y. Okay, that's the normal form of a differential equation. And a lot of times when they talk about differential equations, they'll use that format. Okay, now let's just see. Okay, this is now, I'm thinking about your homework, and I'm thinking about the kind of things that you're going to see in your homework, and this is one of them. Okay, so a differential equation, Amanda, differential form doesn't have dy dx in it. It has a dy and a dx. On the like, if you look at the differential form of an equation, the differential form doesn't have dy dx in it. It has so dy dx is the differential dy over the differential dx. The differential form of a differential equation, they separate the dy and the dx. That's all. And it just involves rewriting the differential equation. You're welcome, Amanda. Great. And let me see here. Hold on. No, Sherman. No, not really. It's just sometimes the differential form of a differential equation is more convenient. Okay, and linearity. So it is important to recognize when you have a linear differential equation. So a linear differential equation is any differential equation that can be written in the highlighted form that you're seeing there from the ebook. You'll notice that this is an nth order differential equation, and y is a function of x. Okay, y is a function of x. So that is a linear differential equation. I'll see, I'm on camera, just to let you know. Okay, so the if you look at it, you see before each derivative there is a function of x before each derivative. Okay, and They have some examples here. I think I'll get right to some examples. Right to some examples. Let me just see here. Yeah, let's go here. So these are examples of linear, well, hold on, one moment. I highlighted the box, but you can't. See, normally I ought to be able to, normally I can color the box, you know, but it's not letting me do it. So let's just, we're in example 4. We're in example 4 here, part A. So there are 3 differential equations there. The first differential equation is in differential form. Okay, you see that? Amanda was asking about that. The first, in example 4, part A, the first differential equation is in differential form. The other 2 differential equations are in normal form. So the equations are in turn linear first, second, and third order differential equations because they meet the conditions of the standard form of a differential equation above. Okay, they meet the equations. They meet the form, and let me see here. Now let me show you what a nonlinear differential equation is. Let me see if they have that. They should. Well, no, yeah, hold on. Let's go to part B. So part B, okay, those are nonlinear differential equations. Okay, so in part B, you see there in front of the the differential equation is 1 minus y times y prime plus 2y equals e to the x. So you see there in front of the y prime, they have a 1 minus y. Well, 1 minus y is not a function of x. If you look back to the definition here, if you go back to the definition of a linear differential equation, all the derivative terms, if they have coefficients in front of them, coefficient functions, which they do, and they have to be functions of x alone. You can't have a function of y in front of a derivative. So if we go back to here now, this is actually working out pretty well, I think. For this hold on, let me just go up a little bit. This example 4, part B, that first differential equation, in front of the y prime, which is dy dx, there's a function of 1 minus y. That coefficient depends on y, that coefficient function. It needs to be a function of x. Now, if we keep looking at these examples, the second differential equation, which is the d squared y dx squared plus sine of y equals 0, well, the sine of y is a nonlinear function of y. Okay, so that can't be allowed. And then the last example there is you have a y squared. You see, you have to have if you have functions sitting alone in the differential equation, they have to be functions of x. Okay, they have, well, I want to be a little bit careful with that, except for, hold on here, let me go back to that. I want to be a little careful here. So you see there in the standard form of a linear differential equation, you see there towards the right, they have the coefficient function a sub 0 of x times y. Well, a sub 0 of x could be 1, by the way, or 2. So you could have just a y variable there, but you can't have y squared or the sine of y. All right, so you're going to have examples in your website homework where you have to identify if the differential equation's linear or nonlinear. And that's the multiple choice part of the problem. So you have to well, normally in website, when you have free response questions where you type in an answer, I give you 100 tries for that. I give you unlimited tries, basically. But when it's multiple choice, the tries are limited. So if it says, hey, is this differential equation linear or nonlinear? Well, you have basically one try at that. So you have to be kind of careful. Okay, you have to be kind of careful. Are there any questions so far? Any questions? If I go, let me go back to that example we were looking at here. Jamie, yes.
Um, so in the definition of that, the can the x's be like a function? So like x squared be in a linear equation, or
Oh,
like y,
yes.
does it just have to be like plain x?
Yes, because if you see there on the right, you see the g of x there, that could be x squared. That would be okay.
Hmm.
Yeah, you could have a big a function of x. It can be x squared minus sine of x plus 2x minus x to the fourth. That's a function of x. So you can have a function of x. You just can't. You can have a nonlinear function of x, but you can't have a nonlinear function of y if the differential equation is going to be linear with respect to y.
Okay, thank you.
Okay, you're welcome. You're welcome. All right, let's see here. Excellent, excellent. Uh, let's see here. One moment, we have another question. Amanda says, so it's nonlinear if the coefficient is a function. Well, what Amanda, when what you need is you need some access to some examples. I think maybe what we'll try to do here is what we'll try to do is in the class, I'm gonna actually probably around 6 o'clock here, give you a chance to get started on your homework, and then I'll be here to help. Okay, so why don't we do that? I think if you do some examples, you're just gonna feel more comfortable. Okay, sound good, Amanda? Okay, good, good, good. All right, all right. So, all right. Let me see here. Let's see. I want to check something real quick. I want to check something real quick here. Just give me a moment. Okay. I want to look at another kind of example uh, so let me stop this recording.